series. And so first of all, let's define what an arithmetic sequence is. It's a sequence in which the difference between successive terms is constant. Notice that key word at the end, constant. Constant means the same. So what that means is that with an arithmetic sequence, we're either going to add the same number every time or we're going to subtract the same number every time. It has to be the same number. And so we call that common difference D. So whenever you see that little d, that means the common difference. And so now what we're going to do is look at some formulas for an arithmetic sequence, and then we're going to look at some problems. So there's the formulas for an arithmetic sequence. Now that second formula is actually one that your book, I don't believe, has in there. Okay, and that's another one that I've used before in the past. But the formula for an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, or a sub n equals dn plus c, where c equals a sub 1 minus d. Okay. D is your common difference, a sub 1 is your first term, and n is the number of terms that you're looking at. Okay? So, go ahead and get that down. So now what we're going to do is we're going to look at a few problems after you get that down. Ready to go? Okay. So now it says determine the common difference and find the next 4 terms of each arithmetic sequence. So this one should be fairly easy because we're doing the exact same thing we did yesterday. So what is my common difference in this problem? Or what am I doing?
Adding.
Adding what?
31.
Adding 31. Okay, so that's my common difference. That's the first answer. Now what I need to do is find the next 4 terms. So I'm going to take negative 67 plus 31, and I get negative 36. Add 31, what do you get? Add 31, what do you get? Add 31, what do you get? There you go. Okay, let's look at the next one. What's my common difference there? What's my common difference? So it'd be a negative 57. That's the key. It's not a positive because we're subtracting it every time. So you were right, it's 57. So now my next one, 130 minus 57 is 73. 73 minus 57 is?
16.
16 minus 57 is? Negative 41. Okay, and then negative 41 minus 57. Negative 98. Good. So far you can handle that? Okay, find both an explicit formula and recursive formula for the following sequences. So I said but it should be 4. So explicit formula, that was the very first one that we looked at. Recursive is one we did from yesterday. So I'm going to show you both. So the very first thing you need to do is you need to identify what the first term is, what the common difference is. Okay, so what's my first term? 12. What's my common difference? 9. Okay, so now we have 2 formulas. We can go ahead and use that first formula, which is a sub n equals a sub 1 plus n minus 1 times d. Okay. So a sub n equals, what's a sub 1? 12 plus n minus 1 times d, which is 9. Now what we need to do is we actually need to simplify that. So we need to distribute the 9 into both. So when I distribute the 9, I end up getting 9n minus 9. So I end up getting a sub n equals 3 plus 9n. And there you go.
The second formula that you gave us, is it, do we have to use it?
No, the second one, I just gave that to you because there might be a time when we might use that as opposed to the first one. Okay, because that second one does come in handy when you know certain things. And so I have 3 plus 9n. So what that means is if I wanted to find like the 10th term, I would plug in 10 for n. Now the recursive formula, if you remember recursive formula, I always start with what? Do you remember from yesterday? I always start with what term? I always start with the first term. Good, thank you. So that will be the first part of your answer. A sub 1 equals 12. Okay? Now, the second part, I'm going to have a sub n equals a sub n minus 1. So really, what am I doing every time? Adding 9, right? You're adding 9 every time. So I'm taking the previous term here, and I'm adding 9. There you go. That's it. Okay, so if you would be subtracting, you would put like minus or something, and that's a recursive formula for that. So always have the first term, and then you always have your relationship between a sub n and a sub n minus 1. Questions?
So what's the answer for this question?
The ones that are boxed. You have two answers. Yep, the explicit is the green, the recursive is the yellow. Okay, so you've got two answers. Let's look at another one. 35, 23, 11. So I start with my formula, a sub n equals. Where do I go? First term
Is
35.
plus n minus 1. What's my difference between terms?
well, -12.
There you go, negative 12. That's what's important. And so now let's go ahead and distribute. So I end up getting 35 plus negative 12n plus 12. So what does a sub n equal? 47 minus 12n. So there you go. There's your first answer. That is your explicit formula. So let's do with our recursive. A sub 1 equals 35. A sub n equals, what am I going to do? Minus 12. Good. There you go. So think you can handle that? All right, find the 68th term of the arithmetic sequence. Find the 68th term of the arithmetic sequence. So what I need to do here is exactly what I did in the previous problem. I need to find an explicit formula. Once I find that formula, I'm going to plug in 68 for n. So let's find a formula. A sub n equals, let's go, 25, yep.
Plus n minus 1 times
Negative 8. Okay, let's distribute the negative 8. So when I distribute the negative 8, what do I get? Negative 8n plus 8. So what do you end up getting now? 33 minus 8n. Good. So now to find the 68th term, I'm going to plug in 68 for n. And that's it. Okay. So I end up getting 33 minus 8 times 68. What does that come out to be? Deb, second? Negative 511? So negative 511 is going to be your answer. So if I wanted to find the 100th term now, you would plug in 100 for n. So whatever term you want to find, you plug that in for n. Okay? All right, find the first term of the arithmetic sequence, for which a sub 25 equals 139 and d equals 0.75. Okay, find the first term of the arithmetic sequence.
We should write our formula.
Yep. So, yep. So now let's plug in what we know. All right? What I know is that I don't know the first term. I know the difference is 0.75. And then I'm going to utilize this little tidbit of information.
That's
Okay? A sub n is 139. Where does the 25 go? For n.
25 minus 1.
Yep, 25 minus 1. Nice job. So now by plugging all those in, you can see that the only thing left we have is a sub 1, so all we need to do now is solve that. So 25 minus 1 is 24. So I end up getting 139 equals a sub 1 plus 18. So what does your first term equal? One what? 121, because all you're going to do to solve that is subtract 18. So all we're doing is manipulating formulas. Okay, manipulating sequence formulas. Should be pretty straightforward. Any questions? I got one more, I think, before we move into series. Okay, so formula, a sub 1. Oh, a sub n. Sorry, there you go. I was seeing if you were paying attention. So let's see what I end up having. A sub 1 equals 75. A sub 38 equals 56.5. Yep, 56.5 over here, 38 here. So once again, we've eliminated all of our variables. So I end up getting, if I subtract 75 here, I end up getting, what is that, negative 18.5 equals 37D. Divide by 37. So what does D equal? Negative 0.5. Isn't it negative 0.5?
Yeah, I was thinking the other way.
Alrighty, so far so good? Okay, arithmetic means. Next thing we're going to talk about. Terms between two non-consecutive terms of an arithmetic sequence. And if you notice, I've color-coded. Okay, so arithmetic means terms between two non-consecutive terms of an arithmetic sequence. So in a sequence of 6 terms, 4 of them are arithmetic means. In a sequence of 5 terms, 3 are the arithmetic means. And so it says write an arithmetic sequence that has 4 arithmetic means between 4.5 and 12.8. So the best way to do this is to create a visual. 4.5, 1, 2, 3, 4, 12.8. This is the first term. This is the 6th term. Now, it says to write a sequence. So in order to have the sequence, I need to know first term, which I do, and I need to know what? The difference. So now the question is, we have to figure out what the difference is. So the reason why I created a visual is because it's a little easier to see what the difference between terms is. How I find the difference is I need to go ahead and subtract the 12.8 and the 4.5, because that's going to tell me how many numbers I have between there. So if I take the 12.8 minus the 4.5, and then what am I going to divide by? 6 minus 1, because I've got 5 different terms to divide that into. So what's 12.8 minus 4.5? 8.3. If I divide that by 5, what do I get? Even? Okay, so what that means is that I'm going to add 1.66 here, in which case that makes 6.16? What do I get when I go here? 7 point what? 82. What's the next one going to be? 9.48. And then the next one will be 11 point what? 14. And then if I add 1.66, so see, that's how it works. But the reason why we filled those in, we really don't need them for this problem, But what I wanted to do is show you how it works. So 12.8 minus 4.5 divided by 6 minus 1. So top here, bottom here. Got it? So then now my difference is 1.66, so my formula, a sub n equals 4.5 plus n minus 1 times 1.66. So all we need to do now is simplify. Oh, I forgot n, didn't I? So I end up getting a sub n equals, what does that come out to be? 2.84, nice job, plus 1.66 n. There you go. So that's your sequence. So that's how it works with arithmetic means. Okay, let's see what we got next. Hopefully, there we go. Okay, so what we have next is we have the sum of a finite arithmetic series. I want you to write this down, and we're going to call this good for today. Okay, we will continue with this tomorrow, and I'm going to let you go on arithmetic sequences on your homework. But like I said, this we'll pick up with tomorrow, but go ahead and get this down in your notes. And we will actually talk about the history of where this formula came from, because this formula did come from somewhere. So once you get that down, I'll show you what your assignment for the section is. It'll be due Thursday. We got it down?
Oh, yeah, you got it.
Okay. I'm going to go ahead and skip through these, and we'll talk about those tomorrow. And there you go. 1 through 8, 10 through 20 for the evens, and 40 through 52 the evens. Okay, 1 through 8, 10 through 24, and 40 through 52.